So what is a scatter plot? A graph that shows a relationship between X and Y. You typically use scatter plots when you're collecting data, okay? Research, when you're collecting some kind of data, some kind of, to see a relationship between an independent variable and a dependent variable. We're gonna talk about the characteristics of scatter plots. So we're gonna look at, is it a positive relationship? Is it a negative relationship? Is the data strong? Is the data weak? Okay, and we're going to talk about what the association is of a scatter plot. But what does a word association mean? Association means the relationship between X and Y. So the relationship between two variables. When we get back after spring break, what we're going to do is we're going to do some kind of experiment with the scatter plot and look at the relationship between two variables. And we're going to collect our own data. So something like you would do in science, where we're going to do some kind of experiment and collect data from that experiment and then read our data in the graph. So let's look at some definitions. So scatter plot, we already said, is the graph of the relationship between two variables. Association is the relationship between those two variables. So there can be, you can either say there's a strong relationship, a weak relationship. It can be a positive relationship or a negative relationship, or you can just have no relationship at all. So we're going to kind of look at all of these descriptors when it comes to the association between two variables. Now, we're really going to dive more into this after spring break, but for some reason, they're having questions tested on it for your quarter 3, 9 weeks exam. So that's why I had to quickly put something in here for scatter plots. We're going to look at, we're not doing this today, but we're going to look at trend lines later on, and we're going to show how trend lines help us predict data. So for example, if I had some kind of relationship between X and Y, and I had some points, and I want to put a trend line, we're going to use this trend line to make future predictions based on previous data. Again, we're not going to be doing that anytime soon. This will all be after spring break. So let's look at an example. Okay, let's look at an example of using a scatter plot with actual a real world example. So Drake was part of a basketball team. He was interested in the association. Remember, this means relationship. Between the amount of time practiced and the amount of three-point shots each player made. The research data that he collected is recorded below. Well, here's my question real quick. We're talking about the amount of time somebody practices and the amount of three-point shots they make. Do you think if they practice more, what should happen to the amount of three-point shots they make? It should go up as well, right? The more I practice, the better I should be at shooting a basketball. And the less I practice, the less I should be, I won't score very much, okay? So Bryce practiced 7 days a week, and how many three-pointers did he make that season? 25. Cameron practiced 2 days of the week, and how many three-pointers did he make? 1, okay? So I want to make sure we know how to read the table. John, he practiced 7 days a week, and he made 20 three-point shots that season. James, he practiced 4 days a week and made 7 three-point shots that season. Well, I noticed the people who practiced more scored more three-pointers, and those who only practiced a couple days a week really didn't score as many three-pointers that week. So what we want to do is we want to make a scatter plot with the table data from the graph. So let's look at this. I don't know if you're at home, you don't have this unless I posted it, and you can print it out yourself, or you can take a screenshot of this and do it along with us. So we're going to plot our data points. So the x-axis is about the amount of time practiced. What do you think our scale should be? What do you think we should go by? ones. I agree. So I'm gonna go ahead and label this 1, 2, 3, 4, 5, 6, 7. There's only 7 days you can practice out of the week. And then we have our y-axis. Our y-axis is about the amount of three-pointers scored during that season. Well, on our table, the smallest y value was 1, and the highest y value is 25. So, what do you think we should scale this by? Threes, I agree. Let's try threes. Let's try threes. So 3, 6, 9, 12, 15, 18, 21, 24, 27. Yep, that's good. That's good. That's good. All right, so we're gonna plot all of our points. So Bryce practiced 7 days a week and scored 25 three-pointers. So 7 days a week, 25 three-pointers would probably be somewhere around here. So this is Bryce. You do not have to label the points, but just plot those points. Liam practiced 6 days out of the week and scored 16 three-pointers. 6 days out of the week, scores 16. That'd be a little bit above the 15. So right here. Brian practiced 3 days out of the week and scored 4 three-pointers. 3 days out of the week, scored 4 three-pointers.
Miss Patterson, wasn't the black point Liam and not Cameron?
Oh, you are so right. Thank you so much.
You're welcome.
See, Dalen, this is why I need you here. All right, Liam. Thank you. I don't know how I thought that was Cameron. All right, Cameron practiced 2 days out of the week and only scored 1 three-pointer. Cameron. So 2 days out of the week, 1 three-pointer. Richard practiced 3 days out of the week and got 3 three-pointers. 3 and 3. Alex practiced 6 days out of the week and got 15 three-pointers. 6 and 15. John practiced 7 days out of the week and got 20 three-pointers. I'm using 7 and 20. What was this guy's name? John? I think so. And then James practiced 4 days out of the week and scores 7 three-pointers. Which color have I not used? Did I use all of them? Gray. All right, 4 and 7. So let's make some observations here. Looking at the graph, what could y'all give me, what would y'all say? And on Zoom, I'm asking you as well. What would you say the trend of the data is? What would you say you notice about the flow of the data, some characteristics of the data?
It's like going in a diagonal upwards.
Perfect. It's going in a diagonal upwards, kind of giving a positive slope feel. I would agree as well. Any other characteristics anyone wants to think of or point out? Now, the positive, it being positive, it going up makes sense. The amount of time I practice, as I increase the amount of time I practice, I should increase the amount of points I score or the amount of 3-pointers I score. So this data makes perfect sense. This data makes perfect sense. Now, we're going to skip making a trend line and predicting our data because we're going to do this later on after spring break. So we're going to skip this part. But what we're going to do is talk about what a scatter plot means and what some terminology and vocabulary is. If you haven't written anything down, this is the point where I would write our vocabulary words. How do I move this thing? There we go. Okay, so we want to first talk about, there's 3 different descriptors we're going to use: direction, form, and strength. So let's first talk about positive, negative, or no association. Which one of these graphs would you say would have a positive relationship or a positive trend? The last one, absolutely. This is going up. The data looks like it's going up from left to right. So this would have a positive trend, a positive association. And right here, this will go with the direction. 2 variables have a positive association if y increases as x increases. So as I'm increasing on my x-axis, my y values are also increasing. This gives me a positive direction, positive trend, positive association. And remember, association means relationship. So the relationship between x and y is positive. Which graph would you say is negative association? The first one, absolutely. This trend is going down. It's a negative trend of values where the variables have a negative association, if y decreases as x increases. So the variables have a negative association if y decreases as x increases. This makes sense. As I go up on the x-axis, my y values are getting smaller. So that is a negative association, negative association. An example of this would be like if I had a huge steak, the more I bit my steak, the smaller the steak would get, right? So the more I did something, the smaller it got, okay? So it'd be a negative association. And then no association would be this middle graph right here. No association, no association. Why do you think this is no association? It's in random places. It's all over the place. I can't tell if it's positively going up, negatively going down. You really just can't tell. So this has no association. No association. No relationship between X and Y. You cannot make any conclusion about this graph or this data. An example of this would be something where they have nothing to do with each other. So for instance, the more I chew bubble gum, does that, if I chew bubble gum every day, should I increase in height or decrease in height? No, bubble gum chewing and height have nothing to do with each other. So this would be two things that really have absolutely nothing to do with each other. All right, so let's talk about form. Form. This is where you're going to be asked on the STAR test. You're going to be asked about direction and the form. If the data points form a linear pattern, it's said to have a linear relationship or linear association. So these graphs on the top here, the left one and the last one, these have a linear association. They don't make a perfect line, but they're forming a line type pattern. So they look like they're going in a negative direction and it's a line. This is in a positive direction. And even though it's not making a perfect line, they're going in a linear direction. If the data is noticeably curved, the relationship is described as non-linear association. So this would be a noticeable curve, So for example, if I had a graph and it looked like this, it is noticeably curved. It is going in a circular curvature direction. Or something like something that has a noticeable curve. All right, and if the data points, there's also strength. There's something strong, or it could be weak, or it could be moderate. It doesn't have to be strong or weak. It could be like in the medium range. If the data points are closely clustered together, like they're really close packed together and forming like a line, it's said that the strength is strong. So if I was to make a strong graph to show you, it would look like this, like where the points are really tightly clustered together. And if the data points are more scattered, but they still form a linear association, you can describe it as weak. So let me do an example of weak. So these still form a linear pattern, but they're kind of more loosely together. So this would be more weak. This would be a weak association. So what we're about to do is look at example problems and then we're done. But I want to make sure we understand the vocabulary before we move on. Is there any questions about the vocabulary? Negative, this is going in negative direction. No association because there's no pattern. Positive, this is going in a positive linear association. Linear, where we'll be forming a line. Nonlinear, where it's curved. Then there's strong if the data points are really tightly packed together, and weak if they're not very packed. Nothing? No questions? Okay. Let's look at some examples then. So what I'm going to do is ask people to give me the direction, the form, and the strength, okay? So all three of these descriptors, I want you to be able to explain. So here's another example of strong versus weak. So this is strong because this data is close together. It's positive because it's going in a positive direction as X increases, Y increases. And it's linear. I was like, what is that? It's linear because it's going in a linear direction. This one would be weak because they're less clustered together. All right, so let's look at this one, okay? I want you to think in your head, everyone get an idea. What would you say the direction is, the form, and the strength? The direction, form, and strength. So just think right now. Don't say it out loud. Just think right now. Direction, form, and strength. All right, do I have a volunteer for this first one? Jayla? I would absolutely agree with you. She said positive, linear, and strong. What do y'all think? Yep. I agree. It's going in a positive direction from left to right. It's forming a line type of pattern. And it is, I would say it's pretty strong. data. Okay. All right, let's look at this one. Can I get someone on Zoom to volunteer?
I can go.
All right.
It's negative, it's linear, and it's strong.
I totally agree. Do y'all agree? Yes. It's negative. It's going in a downward direction from left to right. It is linear because it's forming a line-esque pattern, and it is definitely strong. If I was to put a trend line through this, it is very closely together to the trend line. So yes, strong. Okay, let me pause. Are there any questions about direction, form, and strength? Like someone's like, I'm totally confused. I don't understand why it's linear. I don't understand why it's negative. I don't understand why it's strong. Yeah, we're gonna do that later. So you can just keep that part. Yeah.
Miss Patterson,
Okay.
can you explain a little bit more on why it's linear?
Yes. So do you see how I put a trend line through this? And this trend line is a line. It's a line. It's not going curved like this or flowing in a curvature direction. I did not mean to put all that everywhere. Okay. It is in the form or the direction I could put a straight line through it. Okay. So like even if there are points all around here, they're still going in like, I don't know how to, let me try to think of the wording here. Let me show you an example that would be not linear.
Get it.
Okay.
I get it a little bit.
Like for
Yeah.
example, this right here, well, that's not a line. That would be like a curvature. That would have a curve in it. So the pattern is not very line-like, I guess you could say. All right. Direction, form, and strength. Look at this one. All right, someone else in the classroom want to go for it? Gracie? No association. Perfect. So this has no association at all. There is no relationship between X and Y. There's nothing you can tell. I can't put a line through this. I can't make any kind of form or anything like that. So that has no association. And really, because it has no association, it will have no form. And it's not strong or weak at all because there's no association at all. So perfect. So if you get that there's no association, the rest just follows suit as well. Yeah, because since there's no relationship, there can't be a form and there can't be a string. Questions? Okay, so let's look at these. Would you say this is linear or nonlinear? Nonlinear, because there's a curve to it. Linear or nonlinear? Linear. Linear or nonlinear? Nonlinear. Linear or nonlinear? Linear. So, this is like the part every year where I give people my iPad or I give them the pen and they do it themselves. Anyways, all right. So, can you match? So, instead of doing that, you can just tell me, let me label these A, B, and C. Excuse you. All right. Can I get someone on Zoom? Tell me which graph would you match with a positive descriptor?
A.
Do y'all agree? Yeah, good job. Positive. Someone on Zoom, can you tell me which graph? Someone different on Zoom, would you tell me which graph you would associate with the negative direction?
D.
Beautiful, beautiful, beautiful. Because this is going in a negative down direction. Okay, someone new in the room, which one would you say has no correlation? So that's either Daniel or Allie. C, wonderful, because you can't tell a pattern here. They're just all over the place. Which would leave me with nonlinear. This is nonlinear because it's curved. Okay, so because it has a curvature to it, this is nonlinear. Now, this is an actual star question. This is an actual star question. So if you can answer this correctly, then you should feel 100% confident in these questions. So the question is, don't say it out loud, which scatter plot suggests a linear relationship? So everyone get an idea in your head what you think the answer is. And yes, I'll repeat, this is a star question. Which scatter plot suggests a linear relationship? On Zoom, private chat me what you think the answer is. On Zoom, private chat me what you think the answer is. Give you about 30 seconds, 30 seconds, 30 seconds. Which scatter plot suggests a linear relationship? Private chat me what you think the answer is. Okay. Daniel, you want to tell me what you think?
I think it's A.
Oh, Dalen. Okay, thank you, Dalen. Perfect, yes. A is the correct answer because it goes in a linear direction. What's wrong with B? It's curved, right? If I was to follow this through. Same thing with D. And what about C? No association, no correlation. There's not a relationship there. Beautiful. Beautiful, beautiful, beautiful. Okay, here's another star question. Another star question. Which scatter plot suggests a linear relationship? Which scatter plot suggests a linear relationship? Go ahead and get an idea in your head. And Daniel, I'm going to call on you, so just be ready. But don't say it out loud. Go ahead and private chat me what you think the answer is. What you think the answer is. Which scatter plot suggests a linear relationship? Which scatter plot suggests a linear relationship? All right, Dan, what you think? D, beautiful. This goes in a linear direction. What's wrong with A? Curved. What's wrong with B? No association. And what's wrong with C? It's curved. Okay, I really need to speak up because that's the last slide. Any confusion at all? Can I get a virtual thumbs up if you're fine and you feel like this lesson made some sense to you? Give me that virtual thumbs up if you're good. All right, beautiful. Well, in that case, I hope you have a fantastic 3-day weekend and I will see y'all next week.